Assalamualaikum warahmatullahi wabarakatuh, and greetings to everybody. So in this video we will talk about the division algorithm. So before we look at examples of division algorithm, let's define what you mean by division algorithm. So let's say you have two integers a and b with the condition that b is positive, right? Then we can find the integers q and r such that we can write down a is equals to b times q plus r, where r is in between 0 and b. So this is what we call the division algorithm. Okay, now let's give some names of these variables. Okay, a, the variable a here is called the dividend. B is called the divisor. Q is called the quotient, and R is the remainder. So we're given two integers with the condition b positive. We can find q and r that satisfy this equation with the condition that r from 0 to at most b, right? Alright, so let's look at some examples here. So examples. The first example, let's let a is equals to 7 and let's b equals to 2. So then we want to find q and r here. So we have 7 is equals to 2q plus r, with the condition that r should be between 0 and 2. So the possible values of r is either 0 or 1, and it cannot exceed 2, right? So if r is not equal to 0, note that r is not equal to 0, because if r is equal to 0, it's difficult to get q that satisfy the equation. So r must be equal to 1. So when r is equal to 1, when you substitute into that equation, when r is equal to 1, you substitute here, you have your q will equals to 3. So that you get the equation 7 is 2 times 3 plus 1. Okay, so let's look at the second example. Let's say a is negative 13 and b is 3. So again, we want to find our q and r. So we write down negative 13 is 3q plus r, with the condition that r is between 0 and 3. So the possible values of r could be 0, 1 or 2. Okay, now you can try either one of these values, and you can see that if you get your r is equal to 2, so r is not equals to 1 or 2. but r equals to 2. So when r is equal to 2, you have your q is negative 5. So that will give you negative 13 is 3 negative 5 plus 2. Right? Negative 13 is 3 times the quotient negative 5 plus 2, the remainder. And the way we write down this division algorithm for the values of r is unique. So that's the only possible value of r that we can get that will satisfy the whole equation here. Right? Now let's generalize the division algorithm. Instead just putting the condition where b is positive, we can generalize the form. So again, let's define the generalized form of the division algorithm. So we will let ab be some integers with the condition b is not equals to 0. So b can be negative or positive. Right? And then again we can find two integers q and r such that we have a can be written as bq plus r, the same thing as before, but now r is in between 0 and the absolute value of b. So if b is positive, we have the absolute value make it positive, but when b is negative, again we still have the positive value of b. And let's look at examples. Couple of examples here. So let's say a is equals to negative 2 and b is equals to negative 7. So now we can take the negative values. So write down the division algorithm. We have negative 2 is negative 7 times q plus r, and r will be between 0 and 7. So we can check the possible values of r. Okay, the possible values of r are either 0, 1, 2, 3, 4, 5 or 6. Okay, those are the possible values of r, and you can check one by one. You can check one by one that get a unique value of q and r. So if you put r is equal to 5, then what you will get here is negative 2 is equals to negative 7. The quotient now is equals to 1 plus 5. This is your r. So here we have our q. Q is 1 and r is 5. So you might want to try other possible values of r and to see whether it will also satisfy the equation, and you will get a unique answer actually. The second example, again we will let our a let's say equals to 61, and again the same thing, b is negative 7 for example, right? And write down the division algorithm. We have 61 is equals to negative 7q plus r, and as we know before, r is in between 0, 7. So again we have all 6 possibilities of r from 0 to 6. So which one will satisfy the equation? If you try again one by one, you will get the answer will be 61 is equals to -7. The quotient here is -8, and again we have the same R, 5, right? So Q is -8 and R is equal to 5. Again, you have a unique Q and R. Okay. Now you can look at the special type of the special case of the division algorithm. So the special case here is when R is equal to 0, right? So when R is equal to 0, what you have here is you have something like A is equals to BQ, where plus 0, where R is 0, right? So now you have A is equal to BQ for some Q integer. Now if you notice that this equation, okay, this equation with BQ, we can rewrite that, right? Rewrite that as B A is equal to BQ if and only if B divides A. You remember the B divides A? So here, over here on the left hand side, we call A is a multiple of B, and on the right hand side, B is a divisor of A. So we have a special case where R0, now the division algorithm becomes the divisors and multiple, and this divisor multiple will be discussed thoroughly in the next video. Alright, until then, see you guys. Thank you.